Okay, now you gotta come in.
Hi, Miss Mitchell.
Hey! So we did garbage as a fuel source.
We got a nice picture of garbage here.
So nice. I might move back a little bit because you might be blocking it.
Okay.
But like I don't know.
Okay, so we're starting with characteristics of a good chemical fuel source. So we found 6 main things that describe what a good fuel is. So the first is energy content, and it's the amount of energy a fuel stores per unit volume. And the higher the energy content, the easier it can be converted to a usable form, such as heat energy. Another one is octane rating. Good fuels have higher octane ratings to prevent knocking, which is when the fuel pockets do not ignite at the right times. Volatility measures the liquid's tendency to evaporate. Being somewhat volatile is a good quality for a fuel.
Yeah, should have.
There we go. Okay.
So the last 3 characteristics are corrosion. So in a perfect world, good chemical fuels do not corrode fuel systems. For example, ethanol can increase risk of degradation of rubber or aluminum in fuel engines. Speed of reaction. So in order to be a good fuel source, the speed of reaction must be at a controllable rate that can be harnessed. It cannot be as slow as rust forming or as fast as TNT detonating. And activation energy. An activation energy for a good fuel source should not be too high or too low. If it is too high, then it requires a large amount of energy to even start the reaction. If it is too low, this means that the reaction could happen before the desired time.
So our community of choice was Toronto, Ontario. And here's a nice picture of Toronto. So why garbage is a good fuel source for Toronto, Ontario? As the largest city in Canada, we thought that since it has a population of over 2.5 million people and it's the capital of Ontario... Sorry, I should stick it. Okay. The capital of Ontario, it produces more garbage than any other place in the country because of it has the highest population in all of Canada. In Toronto, garbage is plentiful and easily accessed, and because of this, their supply of garbage will never run out.
We are always producing garbage.
Yes. Garbage is renewable, and using it as a fuel source is good for the environment, and garbage as fuel is very inexpensive, which is great for consumers and also the government if they're funding the fuel sources.
So the most common ways of producing fuel from gas. So there wasn't really one common way of doing it. In the beginning, incineration was the most common way of producing fuel from garbage, but nowadays combustion, pyrolysis, thermal gasification, and plasma arc gasification are more common because they're better for the environment than incineration was.
So the advantages of garbage as a fuel. First of all, landfills would disappear as the garbage would be removed from them and it would be reused. Garbage is a cheap fuel, as I mentioned before. Garbage is a reliable source of fuel because the cycle of waste garbage production is never ending. Building waste to energy plants would benefit the economy greatly by providing many jobs, so great for the labor force.
Yeah.
And the U.S. Environmental Protection Agency deems that it has less of an environmental impact than any other source of electricity. And also, monitors are used to confirm that the number of pollutants and toxins being released into the air is not too great. So it's definitely environmentally friendly.
So the disadvantages of garbage as a fuel, waste-to-energy facilities are expensive to construct. As you can see, this one is very elaborate. If pollution control is not followed and monitored strictly, it will damage the environment. So if the if the monitors aren't being checked regularly and like filters are cleaned, then it can really hurt the environment.
So the history of waste to energy. The first waste to energy facility, or incinerator, basically, in North America was built in 1885 in New York. Waste to energy facilities became more common up until the 1970s when new standards were put into place and they banned the uncontrolled burning of municipal solid waste and placed restrictions on certain emissions. Most facilities did not end up meeting these requirements, so that most of the facilities did get shut down. And then they tried again in the 1980s by installing pollution control equipment. However, in the 1990s, there was an issue with mercury and dioxin emissions, and most facilities had to be shut down again. So unlike the facilities in the 1970s and 1980s that were thought by the public to be dirty because of poor emission control, garbage as a fuel is now a clean, refined and well-managed process. Good old PS3.
Producing fuel from garbage today, pyrolysis. This is one of the methods we mentioned. Yeah, one of the new ways. So pyrolysis uses heat in the absence of oxygen to break down materials under pressure. It produces a variety of combustible gases, liquids, and solid residues such as methane, carbon monoxide, and complex hydrocarbons. The process happens in a rotary kiln, rotary hearth, furnace, or fluidized bed furnace, so which are all similar to incinerators, except there's less air supply. Particulate removal technologies filter out contaminants and toxins at the end of this process.
So then we have thermal gasification as well. Similar to pyrolysis, except thermal gasification of waste takes place when there is a limited supply of oxygen instead of none at all. The gas produced by pyrolysis and thermal gasification can be used to provide heat in boilers, or the gas can be cleaned up and used in combustion turbine generators. Gases, oils, and solid char that are created by these methods can be used as feedstock, which is another word for raw materials, for chemical production or other applications.
Plasma arc gasification. This method uses a plasma torch with temperatures as high as 13,000 degrees Fahrenheit, so it's really hot, which breaks down wastes, forming syngas and a byproduct called slag, which is used in the construction or the making of pavement and asphalt. Syngas can be converted in gases such as methane, ethanol, and hydrogen, or used to generate electricity.
So energy efficiency. It is not possible at this moment really in time to determine the efficiency of garbage as a fuel. This is because it's not a common source of energy. We don't really use it that often in Canada. It's just kind of a new thing that's happening. So the new technologies for waste to energy are in a very early developmental stage. However, many sources believe that garbage as a fuel has the potential of being very efficient.
Impact of fuel from garbage on the local environment. So it impacts air emissions because, like I said before, if things aren't monitored very closely, there's a possibility for a lot of toxins to be released into the atmosphere. Land resources are used, so these buildings that are used to convert garbage to fuel are really, really big and, like I said, really expensive. And then water resources are used because for every bit of garbage that is broken down, there needs to be a certain amount of water used, and so that uses water resources. And then water discharges, so that water that was used to break down the garbage then gets thrown out, and it's not usually thrown out properly, and it goes into the water systems and goes into the ground. And
so we have some examples of air emissions and little dead fish. Pretty sad.
Poor guys.
Yeah. So, the development, the science we think that is needed to make this fuel is thermochemistry, which we are just finishing up. Thermochemistry is the science needed to convert garbage to energy because between incineration and all the other methods, the new methods used, heat is always the main component in the process. And here we
actually have a little poster.
we made. Some of our props.
So as you can see, combustion, gasification, and plasma or gasification, and pyrolysis all fall under the thermal category. So
Yeah.
thermochemistry.
And so combustion creates heat. Gasification, plasma and thermal gasification make fuel and gases. And pyrolysis results in char and gases.
So that's that.
Yes, it is. All right.
That's why we're excited. So basically,
We start with some garbage, as we have here.
it gets broken down and
Goes
with
through the
heat,
processes.
and then we end up with
Energy.
a flashlight, some energy. So yeah.
So thank you for watching our presentation, Miss Mitchell. We hope you enjoyed it. We apologize for the poor quality of our screen, but we will send you the slideshow, and hopefully that's enough. So
Yeah. Okay.
thanks.